Hello dear students, so how are you all? This is your chemistry teacher Mukesh Jangir. So we are discussing what? Periodic table chapter, and today's topic is ionization energy. Okay, so what is today's topic? Ionization energy. So let's start the topic. First of all, I will give the information and the definition of ionization energy. Then we will understand the basics and the depth of topic and what questions may be asked in your exam. So let's start with the definition. So what is ionization energy? Ionization energy is what? Minimum energy is required to remove most loosely electron bonded to an isolated gaseous atom. What I told you? I told you that there is an atom. Wait. So this is an atom, and these are the different cells of this atom, and these are electrons bonded to it. Okay. So these are some electrons bonded to this atom. And now, what is ionization energy? Ionization energy is an amount of energy. Listen carefully. Amount of energy. What that work? That work to remove an electron. And which electron? Electron is this. Maybe this, maybe this, maybe this, and maybe this. Why? Most loosely electron. And you know, the electron closer to nucleus is powerfully attracted, and electron far away from the nucleus is loosely bonded. So you have to remove the outermost cell electron, that is most loosely electron. So we are removing this, and the amount of energy which required to remove this electron is called ionization energy. I think the point is clear. So this is ionization energy. Again, point to point, minimum energy required. The amount of energy that should be minimum. Remove most loosely held outermost cell electron. And you understand this thing? Different cell, outermost cell, and most loosely electron is outermost cell electron in ground state. Yes, this is very important point. The electron should be in ground state. Why ground state? If electron is excited, you know what is excitation? If electron isn't to a cell, this is ground state. And if it is excited, then this electron move to 2p or 3s cell. These are excited state. You have studied in atomic structure. Excited state means the electron in higher energy level. Okay, so electron should be in ground state. Next point. An isolated gaseous atom. Okay, electrons should be in isolated gaseous atom, not in bonded conditions. Okay, now I am explaining these points again. This is an atom. First point, this is gaseous atom. This is not solid. If you consider electron is removed from solid state, that will be not ionization energy. Okay, next point, ground state, that should be clear initially that electron is in ground state. Next point, isolated. What is the meaning of isolated? Listen and watch carefully. This is a molecule and bonded with N. This is bonded condition. Okay, this is bonded, not isolated, and we are considering what? Isolated means not bonded with any other atom and not bonded with other atom of itself. Should be isolated. Clear? So electron should be isolated, should be in gaseous state, and should be in ground state. And electrons you are removing must be outermost electron. I think the basic definition of ionization energy is clear for you. Okay, now move to next slide. This thing I have already explained you, but again let's read. Electron cannot be removed from solid state of an atom. As I told you in last slide, it has to convert in gaseous form. Okay, if you have an atom in solid state and you want to remove electron, first of all, the important thing is what? Electron cannot be removed directly from solid state. If you want to remove electron M to M plus, this is not possible. Okay, so electron plus electron, this can't be ionization energy. Okay, so what you have to do? You have to do what? First, convert this atom into gaseous state. Clear? First, you have to convert into gaseous state, and you have, and you know this thing that if you are converting solid directly into gaseous state, this process is what? Sublimation. And energy required is what? Sublimation energy. So, first you have to provide sublimation energy to that solid state atom. Then it will be converted into gaseous state, and now you can easily convert into M plus gaseous. And this energy required to remove the electron, M gaseous state, M plus gaseous state plus electron, and you are remove the electron, and the provided energy is what? Ionization energy. And complete this sentence. Energy required for conversion from solid state to gaseous state is called sublimation energy. Clear? Very good. IP or I. One point. IP and IP. You can call it ionization energy, you can call it ionization potential. There is a basic difference between these two, and I am not going to explain. Why? Because you have already studied these things in atomic structure, the last chapter. Okay, so ionization energy, IP or IE, you can call it IE. Okay, it's always an endothermic process. Yes. What is endothermic system? Endothermic system what? You have to provide energy. Okay. We are providing the energy to this system. So this is endothermic system. If we are removing energy from this system, or this system is releasing energy, then that will be exothermic system. So clear? What I have told you till now is what? Check. An atom should be in gaseous state, should be isolated, and it is converting into this, and the energy required is called ionization energy, and this energy is positive. So positive, and the system is endothermic system. Okay. Clear? Very good. So next, move to next slide. Next point. For an atom M, successive ionization energies are as follows. Listen and watch. You have an atom M in gaseous state. You removed an electron. Okay, and the atom converted into M plus ion. You have provided the energy IP or IP. Let it consider IP. Okay? IP1. If you are remove the first electron from this isolated gaseous atom, then it will be IP1. First ionization energy, first ionization potential. And now, if you want to remove one more electron from it, so we have removed another electron minus E. Now you have to provide another ionization energy, that would be IP2. Okay? Now you say, sir, we want to remove one more electron. Okay? Let it. So, and plus 3. One important thing is that all are in gaseous state. Okay? Keep in mind. IP3. And electron is 0. So you can see here, we have removed electrons successively, and then M plus, then M2 plus, then M3 plus. And the energy required to remove this successive electron from the atom M are successive ionization potential or energy. That is what IP1, IP2 and IP3. Clear? Very good. Now a question arises. If you are asking, or if I am asking to you, that what is the order of energy IP1, IP2 and IP3? You can see it. Sir, this is the order. Okay, very good. This is written here, so you can say it. But what is the reason behind the order of successive ionization energy? Why IP3 is maximum and IP1 is minimum? Okay, listen carefully. Initially, we have atom Mg. Okay, we have removed one electron and M convert into M plus. And you know one very important thing we have discussed in last lecture in atomic size. What is that? If we remove electron, it is converted into ion and its size is decreased. Again, we removed electron, its size is decreasing more. And now the point is, you have two atoms. One is small sized and one is large sized. You tell me, in which case more energy is required? You can clearly say that this atom is small, so required energy is higher. Because this is closer to nucleus. Closer to nucleus means more attraction towards this electron by the nucleus. And in this case, this electron is far away from nucleus, so low energy is required. So it is clear, smaller the size, higher the ionization energy. And here you can see it. Electron is removing, cation, more positive charge and more smaller size. And more smaller size, then what will happen? More the ionization energy. So order of size is decreasing, so order of ionization energy is increasing. I think the point is clear to you. Okay? Very good. Next, move to next point. Factors affecting ionization energy, the ionization potential. What are the factors? And we have discussed these factors already 2 times in effective nuclear charge, of course, screening effect topic, and atomic size. And very important, I have just discussed in the last slide atomic size. Okay, first point, more Z effective. You know, as the Z effective increases, attraction power increases, size decreases, and of course, smaller the size, higher the ionization energy. So you can see it, higher Z effective, higher ionization energy. So Z effective is higher, IP is higher. Next, smaller the size, okay? Smaller the size, higher the ionization energy. One is higher, one is smaller. So you can see it inversely proportional to it. Okay? Next point, screening effect. What is screening effect? Remember, Z effective, Z minus sigma, and what this sigma works? This sigma is actually repulsion of electrons. And you can see it, more repulsion, more sigma, and more repulsion by electrons, electron can easily remove. Okay? Easily removed. So electron is easily removed. So higher repulsion, lower ionization energy. So both are inversely proportional to each other. Next is electronic configuration, and electronic configuration we will discuss later. Okay, so in this lecture we have discussed the basics of ionization energy, what is ionization energy, and then factors affecting ionization energy. Okay, thank you. Jai Hind.